Thank you. Okay, yeah, so I get to talk about quite an exciting topic, which is Bluetooth getting put into labels for tracking applications. I'm going to go through a few things just so you have the context. We'll talk briefly about Bluetooth tracking and how that fits into the world. I'm going to show you a bit about Bluetooth Smart Labels, what's made them possible and what they enable. We'll go a little bit into how it fits in with RFID and barcode technology so you can see how they fit together. And then perhaps give you a view of how these are actually being used in action and even a way to trial them in your own environment. Okay, so Bluetooth beacon tracking, you're probably familiar with this even if you didn't know it. It's been around for at least 10 years as core technology. I guess more recently popularized and shown the potential with consumer tracking networks, things like Apple's Find My network for tracking things like AirTags or even devices that have beacons built in. So you're probably familiar with this. You have a Bluetooth device that can transmit a beacon. That can be spotted by a network of listening hotspots or devices. In the case of Apple's network, that's their mobile phones. And then that can be fed into some application. So in the consumer space, that's to find something that you've lost or your child that you've lost or whatever it might be. Well, it's very similar in the commercial space, but obviously a lot of the parameters are a bit different. So in our case, we work with Bluetooth tags in different form factors. They might have sensors in them as well. You'll probably recognize the plastic tags that are attached to equipment and assets to understand what they're doing and where they are. We're also going to talk about these labels, though, which are newer on the scene. Often these are spotted by gateways that are pre-installed in environments. In our case, we're lighting up the sort of devices that people already have around their companies, around their warehouses, around their shops as the tracking network. So that might be Zebra devices that you're used for barcode scanning. Well, we can enable all of them as a beacon scanning network. So companies can turn on the devices they already have as a way to spot and track assets around their business or around their supply chain. And then that all gets pulled together into a network that can be fed into a back end. So that could be as simple as a visualization of where things are in the world, or it could be feeding into databases, data lakes, AI systems, whatever custom cloud applications there might be to go and ask the questions that people want of this data. But I guess what we're interested in today is smart labels, which have been in development for quite a few years, but I think this year is going to be the year that you'll see them used a lot more widely. So this is an example of a label. I probably have one here. So this is a label that's a sticky label that has a Bluetooth device and a battery in it. So you can see that can just be adhered to a product or put through a printer. And you can start to see the components that are going on inside. And this is the magic that has made these possible. So there's really three main components that go into a Bluetooth label. You have a very tiny Bluetooth chip. So this is to scale. This is a pound coin here. So a minuscule piece of silicon that has a full Bluetooth radio on it and a controller that can control and send messages. You then have printed battery technology. So rather than coin cells that are often powering these things, this is a battery technology where you actually print down the materials to form a battery. And in this case, based on zinc rather than something like lithium. That tends to make it much more applicable to being disposed and things like that. And then you have the circuitry that pulls this together, which either is using like an RFID process, like a printing process, or it's like a flexible PCB process. And the advancement of these three things have sort of come together to enable what is a sticky label that has Bluetooth built in. So this is the one we are using with customers at the moment. If you peel it off its backing, that's what activates it. It will then last at least a month, transmitting and being spotted by a network. It can actually last a lot longer than that. As you saw, it's very thin, so it can be attached to some packaging or something like that without it causing issue or, in fact, even being particularly visible. You can have temperature sensors built in, so perhaps if you're monitoring cold chain type applications, you can actually see temperature deviations through a supply chain. Currently, I would say these are in the sort of $5 range at the phase we're in now, maybe $3, $4, something like that. But if you look at the way they're constructed and the materials they're constructed out of, this is going to get sub-dollar relatively quickly. They're certainly not super cheap, but $1 or $2 for one of these things for the value it's giving to a lot of people, the ROI works out. A lot of the ROI is actually based on the fact that you don't necessarily need even to return these versus a normal tracker, which would generally be within a package rather than on a package. We have a whole white paper if you're interested on going much deeper into the actual technology of these labels and what they're capable of, so you can obviously go and find that if you're interested. But let's quickly go into how it fits in with RFID and barcodes. So these are sort of three complementary technologies, going from incredibly cheap, basically printing, to passive RFID, which is a few cents to 10 cents, to active Bluetooth, which is in the sort of dollar range. But the main differences are things like an active Bluetooth thing can be transmitting a long distance, 100 meters, whereas a passive RFID is a very short distance. You can obviously scan barcodes or Bluetooth with a normal infrastructure, a laptop, a phone. RFID is custom. So what you find is that there's actually use cases where these come together. So you might have people stacking a pallet and they're enumerating exactly what goes into that logistical unit by scanning barcodes or maybe scanning the whole pallet with an RFID reader. That's great. In your warehouse, you can have that dedicated RFID infrastructure all the time to allocate it. When it goes out into the world and you're trying to work out where it's going, you might actually tag that whole atomic unit with a Bluetooth tag. And you know what is in that unit, so indirectly you're tracking everything within it. So you can see how these sort of technologies, they have different price points, they have different trade-offs, and they kind of all work together to give a really high visibility picture of what's going on. So what does it look like? Well, they're pretty simple. They're labels, they're sticky, and it's pretty obvious what happens. So this is out with a company that does pallet tracking, or they move a lot of pallets. The label is peeled to activate it and stuck onto something that has a value which people are interested in tracking. It's just attached on and inducted into the system like you would induct anything else by scanning the QR code on the device. And that means it fits into a workflow that people are doing already. They get reels of labels printed out, they attach them to the products, and then they go out into the world. It's pretty normal. What's quite interesting with Bluetooth, though, is all of these people, you can't see it very easily, but that guy's carrying around a Zebra device because he's doing his job. That's what tells him what to do. All the time these devices are moving around because they've been enabled with our agent to act as scanners. Actually, they're doing work even while he's just walking around the site. So you're getting a picture of what's going on, even without any manual intervention. And it's not just true of walkers. This is an example of a guy who's zipping around on his forklift truck, working out what job he has to do next. But of course, he's got a Zebra device mounted to his forklift, and that's acting as a Bluetooth scanning network as well. So you're getting pictures of the movement of these packages throughout a whole supply chain. So it becomes a really cheap way to roll out tracking across a whole supply chain because all of these devices already have Bluetooth in, and you can pick up these labels from, like I say, 50 meters away. And what do you end up with? Well, you end up with a feed of data. So this isn't that customer. This is just where we've been traveling with labels on some of our stuff. But you can see you start to get a really good picture of what's actually going on. So this is just feeding the data from our network into a tracking visualization. And you start to really see the data coming to life. Obviously, this is generally going into systems where people are doing slightly deeper analysis, but you get the idea. This technology is now real. So we have sample kits that people can use to test it in their organization if they're trying to understand if this technology can be applicable. So if you're interested, we have a page on those smart labels, and you can order a kit of them to roll out to some devices and try it yourself with your own scenarios or integrating into your own infrastructure. Thank you very much.